Hello friends, hearty welcome to you. In this session, let's try to look at this interesting example related to circles and tangents. We have to find out the length of AC and AB of the given triangle, which is having a incircle centered at O. We also have been given that BC is divided into two parts, or the point of contact is at D, such that BD equal to 8 and CD equal to 6. We have to find out what is the length of AC and what is the length of AB. So what is the approach we will follow to solve this problem? To solve this problem, we will use three concepts. The first concept is length of tangents are equal. Length of tangents drawn from an external point to a circle are equal. So that concept we'll be using related to length of tangents. Second concept what we'll be using is we know that line drawn from center to point of contact, or the point of tangency, is always at 90 degrees. Line drawn from center is always at 90 degrees. That's the second concept we'll be using. And the third concept we'll be using is area of triangle. How to find it out? Using two different methods. One is Herons formula and the other one is standard formula, which is nothing but half into base into height. So these are the three concepts what we'll be using one by one to solve this problem. So first what we will do, we will use the length of tangents. What's the meaning of that? The theorem says that if two tangents are drawn to a circle from an external point, then the length of those tangents are equal. To move forward, let's try to name them as this point is equal to E and this point is equal to F. So we have D here, we have DEF. Okay. Now, according to this concept that length of tangents drawn from an external point to a circle are equal, if CD equal to 6, CE also will become 6 centimeter. Similarly, if DB equal to 8, BF also will become 8, according to the theorem that length of tangents drawn from an external point to the circle are equal. Now we don't know about AE and AF, so we will take it as X. We will say the length is X on that side and also length is also X on this side. So now we have the triangle ABC. Triangle ABC is with sides. What are the sides of the triangle? The sides of the triangle are AB equal to X plus 8, BC is 14 and CA or AC is X plus 6 centimeters. So we have AB here, then we have BC, we have AC. Okay. Now the next point what we said is line drawn from the center to the point of contact is always at 90 degrees. How that will be useful to us? So we are saying that this is 90 degrees and also that's 90 degrees. That is also 90 degrees. So how we will leverage that is basically we will try to join OA, OB, OC. We join O to A, O to B and O to C. When we do that, we divided the triangle ABC into three parts. What are the areas of triangles? We will find it out. What are the triangles? Triangle ABC is divided into three parts. One is triangle BOC, the other one is triangle AOB and the other is triangle AOC. Now what we did is we divided the triangle into 3 equal parts. So what's the approach here? We will find out the area by using half into base into height by dividing the given triangle into three triangles as we have done, BOC, AOB, AOC. And also we will leverage Herons formula because we know the sides of the triangle. We will equate the areas found by both the methods so that we should be able to find out the value of x. So that's the approach we want to follow. So let's go ahead now and try to find out each areas. Triangle BOC area is nothing but half into base into height. The base is 14 and the height is always 4 because the radius is 4. So can I say half into BC into half into 14 into 4. Let us plus there because we know we need to add them, plus half into AOB, base is x plus 8 and what is the height is 4, plus triangle AOC, that is half into x plus 6 into 4. Now let's try to simplify this. We can cancel 2 here, half again into 2 times, half 2 times. I can take 2 common. If I take 2 common, I'll have 14 plus x plus 18 plus x plus 6, or can I say that's equal to 2 into 2x plus 28. Or can I simplify that further, factorizing with 2 one more time? I will have 4 into x plus 14. So the area of the triangle in one method we found out is equal to 4 into x plus 14. So before we move forward with Herons formula, let me just recap what we have done. We have been given a triangle ABC. We have been told that BD equal to 8 and DC equal to 6 and D is the point of contact. We have to find out what is AB, what is AC. So we want to leverage 3 concepts here. First concept is to start with the problem. Length of tangents drawn from an external point to a circle are equal. By that we will have EC equal to 6 and FB equal to 8. We don't know what is AF and AE, but we know both of them are equal because from A you are drawing tangent. So let us say that is X. Now once we have done that, now we have found the sides of the triangle as x plus 8, 14 and x plus 6. Now how to find out the value of X? For that we will leverage the area of triangle. We will find out the area of triangle in 2 different ways. One, we will divide this triangle into 3 parts and we'll find out the area by using the formula half into base into height. And the second thing is we will use Herons formula and find out the area of the triangle because we know the sides of the triangle. Now let's go ahead and find out the area by Herons formula. After that we will equate both these areas because both of them should be the area of the triangle. It should be the same. So that will give us the value of y. So let's move forward. So Herons formula is given by area is equal to square root of s into s minus a into s minus b into s minus c, where s is called as semi-perimeter or semi-perimeter, given by sum of the sides divided by 2, or nothing but half of the perimeter. Now we know the values. AB is nothing but small c and BC is small a and AC is small b. We know that. If we have the side BC, then its length is nothing but opposite vertex in lowercase, that is small a. Okay. Now let's find out the area by using this formula. For that we will go to the next step and we will say area equal to, first I have to find out S. So let me write down here what is S. S equal to A is 14 plus B is x plus 6 plus C is x plus 8, this whole thing divided by 2, that's equal to 2x plus 28 by 2, or can I say x plus 14. So we got s is equal to x plus 14. We got s equal to x plus 14. So let's use the formula now. A equal to square root of s is x plus 14. Multiply that with s minus a, that is x plus 14 minus a is nothing but 14, and s minus b, that is x plus 14 minus of x plus 6, that is minus x minus 6. Multiply that with s minus c, that is x plus 14 minus x minus 8. Let's simplify this. We will have, if I simplify, 14 will cancel, x will cancel, x will cancel. So I'll have x plus 14 multiplied with x, that multiplied with 8, and that multiplied with 6. So can I say that's nothing but equal to square root of 48x into x plus 14, because 8 6 are 48, we are multiplying with x into x plus 14. So other way, what is the area we found out is square root of 48x into x plus 14. This is the area we obtained by using the Herons formula. So the next step will be, we'll be equating both these areas and we'll find out the value of x. Let's equate both the areas. Whatever we obtain for the triangle ABC, we have 4 into x plus 14 is equal to square root of 48 x into x plus 14. Now simplify that. Since we have square root, we'll do sobs, squaring on both sides. That will give me 16 into x plus 14 whole square is equal to square root and square will cancel out. I will have 48x into x plus 14. So let me just try to simplify this by taking everything to left hand side. So I will have 16 into x plus 14 whole square minus 48x into x plus 14 is equal to 0. Now I can take x plus 14 common, I can take 16 common. So I will have 16 into x plus 14 and multiply that with, left out x plus 14 there, and we are left out with minus 3x here. I hope you are okay with that. We have taken 16 into x plus 14, we are left out with x plus 14. Here we are left out with 3x. When I simplify, I will have 16 into x plus 14, multiply that with 14 minus 2x equal to 0. Now x plus, so this tells me that x plus 14 equal to 0, or 2x minus 14 or 14 minus 2x equal to 0. This will give me x equal to 7, and the first equation will give me x equal to minus 14. But this cannot be negative, so that's ruled out. The value of x is 7. So once x becomes 7, what will be the sides now? Side AC is equal to 13 and side AB is equal to 8 plus 7, 15. So the sides of the triangle are 13, 15, which we found out given is 14. So we can find out now, we can cross check by finding out the area. You can do that substituting in this method. You will be getting the area is equal to 84 square centimeter. You can check that. Let's substitute here. 4 into x plus 14, 4 into 21 is 84. Here we will have 48 into x is 7 into 21. That's nothing but equal to 7056, and its square root is 84. Or I can write 7 into 3, so that 7 will come out. 144 will give me 12. 12 into 7 is 84. So the sides are, which we have to find out, AC is 13 and AB equal to 15. So the sides of the triangle are AB 14, AB 15, BC 14 and AC 13. So how we have solved this problem? Three things we have considered. One, length of the tangents drawn from an external point is equal. Second, then we have leveraged that we have kept all the sides. We found the sides but they are not in variables x. So we have to solve the value for x. For that, since we have been given radius and we know that at point of contact between tangent and a circle the angle is 90 degrees, I can find out the area of this triangle by dividing it into three triangles and using the formula half into base into height. Also we know the area by Herons formula because we know the sides ABC. Herons formula gives area equal to square root of S into S minus A into S minus B into S minus C. Now we equate both the areas, we are able to find out the value of X, which will give me what's the value of AC and AB. So that's one interesting example from circles 10th grade syllabus where we are looking into the length of tangents drawn from an external point is equal, and we are leveraging the previous knowledge of how to find out the area of triangle in two different methods. So I'll catch you once again with another interesting example. Thanks for your time and support. Keep smiling. Bye for now.